Okay, in this lesson we are going to look at how we can use trig ratios, or trigonometric ratios, we just call them trig ratios for short, how we use them to find the length of a side we don't know, or an unknown side. Now I say part one because this is going to look at one particular type of question. There's another one we'll look at in a future video, but for today let's take my right angled triangle, and I know it's right angle because of this symbol. Remember, these trig ratios we can only use for right angled triangles. And here's some details. I've got an angle of 30 degrees here. I've got a length of x, which I don't know. That's my unknown side that I'm trying to find out. And I've got a length of 18 for this side. Now, the task here is to find the value of x. In other words, the length of this side. Now, what do I have? Well, if this is my angle of reference, over here is my opposite, isn't it? It's the side that's opposite my angle. And this side, we know it's the hypotenuse. It's the longest side. It's also the side that's opposite the right angle. I've got nothing. You'll notice I've got nothing about the adjacent side. So here are my little phrase to remember my trig ratios. SOHCAHTOA, sine equals opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Hopefully you remember that from a previous video. Now looking at this, I've got some information about the O and the H. I've got something here and here, but nothing with the A. So I can't use anything with an A in it. So I'm going to have to use this sine. This is going to be a sine ratio question because I've got opposite and hypotenuse. So let's write that out. I know that the sine of 30 degrees, because that's my angle of reference, equals the opposite over the hypotenuse. So the x over 18, my opposite over my hypotenuse. And now I've got a little equation that I can use to solve for x, and hopefully you might remember from previous work, you can use our algebra skills to get x on its own. Now I'm going to show you two methods, my preferred method and one that's a little bit more traditional, so you can use whichever works for you. Now sine 30 is a number. If we put that in our calculator, we can get a number. So here's how we go about getting x on its own. If the letter or the unknown side is on the top of the fraction, all we need to do is take the number on the bottom and we drag it across to the other side in front of the trig ratio. I took it from the bottom and just dragged it across. So now I've got x on its own, and this is something I can put in my calculator. I can literally just type in 18, hit the sine button, 30 equals, and I'm going to get an x value of 9, or an answer of 9. So in this case, the length of the unknown side was 9. All right, good job, well done. Now a little more traditional algebraic method, and I'll just quickly show you so that for those of you who do it this way, it show you that it works exactly the same. Here's my ratio, so we're back at this point. But looking at this, you can kind of go, all right, well, what's the opposite of divide by 18? Well, it's times by 18. Okay, whatever I do to one side, I have to do to the other. And the reason I do that is now I can cancel out my 18s, and I'm left with x equals 18 sine 30. So it's the exact same result. Put it in your calculator. It's just using a little more traditional. Me personally, I like to just remember, hey, if the unknown's on the bottom, if the unknown is on the top, drag the denominator across. All right, let's have a look at one more example. This right angle triangle here, I've got an angle of 32 degrees, and I know that I'm going to use one of these three trig ratios, so sine, cos, or tan. Looking at this, I've got some information about the opposite. I know that it's x. And I've got something about the adjacent, because this is the angle, the side that's touching or adjacent to my angle. But I've got nothing about the hypotenuse, no information at all. So I can't use anything that's got an h in it. So this is obviously going to be a tan ratio question. Okay, tan equals opposite over adjacent. So the tan of 32 degrees, because that's my angle of reference, equals the opposite, which is x, over the adjacent. So opposite over adjacent. And you can see, very similar to the previous question, now I've got an equation. My unknown is on the top, so I take the number on the bottom and I simply drag it. I'm going to rewrite that so you can see it. I simply drag it across in front of the trig ratio. Whack that in my calculator, 8.4 tan 32, and I get a value of 5.25. So the length of side x, my unknown side, was 5.25 meters. You guys are amazing. You just used trig ratios to find the length of the unknown side. Okay, good job, well done.